My name is Ray. Welcome back to another episode of Ray's Economics Cluebook. Today, we'll be talking about our ADAS model and talking about how income and expenditure affects it. So first of all, when it comes to spending, consumer spending, there are two factors that affect the consumer. There is the marginal MPC and MPS, and they both add up to 1 or 100% of the disposable income. So basically, look at this graph. We see their change in disposable income and then change in real consumer spending. And each unit of change for disposable income, the real consumer spending goes up or changes by a certain amount in this constant graph. And the slope of this graph equals MPC, or our marginal propensity to consume. Now, this means that our marginal propensity to consume basically equals our change in spending over our change in disposable income. And why is this the case? Well, because when we receive an increase perhaps in disposable income, usually consumers on average do not spend all of that increase. They save part of it and they spend part of it. And the proportion that they spend is our MPC. The proportion that they save is our 1 minus MPC, or our marginal propensity to save, or MPS. So that overall adds up to our overall graph here of a change in disposable income compared to change in consumer spending. Now, we see there's a difference here because this adds up because our previous graph we look at individual consumers and their change in disposable income and change in spending. But now we see the aggregate consumption function for the consumers within an entire economy. Now, in our aggregate consumption function, we see a bit of a difference here. Overall, it's still a straight line on average, but we see that the y-intercept here is positive, and it's approximately 14,184 here in this graph. Now, this was not nearly as present within our individual graph. Now, this y-intercept here basically represents our consumer spending when the consumer has zero disposable income. This is called our autonomous consumer spending, and basically this still occurs because at the end of the day, even if you have no disposable income, you still have necessities to pay for. And to pay for these necessities, such as food or water, you have to conjure up money in some other way, such as, for instance, taking a loan, selling off your possessions, or etc. Just finding money in some way outside of more traditional disposable income. So that's our autonomous consumer spending. But we see here, overall, our consumption function is still relatively the same outside of that. And here our fitted consumption function is 14,184, our autonomous consumer spending, plus 0.597 times change in disposable income. So how does this have an effect on the aggregate economy as a whole? Well, to begin with, this impacts our multiplier, which plays into our economy. The multiplier is basically, let's look at an example here. So let's say I spent $1,000 I pay a contractor $1,000 to fix something with my house. So the aggregate change in autonomous consumer spending will be $1,000. So now the contractor has $1,000, and the contractor with that $1,000, that's his or her change in disposable income. So that $1,000, he or she is going to save a part of it and then spend part of it. And the part they spend, or their MPC, is basically their impact in the economy after we give them the $1,000. And let's say the contractor spends let's say $800 out of that $1,000, so our MPC is 0.8. They spent $800 on let's say food at the grocery store. So the person at the grocery store receives the $800, then saves part of $800, and they spend 0.8 of the 80% of the $800. They spend $640, and so on in this chain of spending and saving. So basically, our $1,000 basically had a chain reaction on the economy. Basically, chain reaction is basically our autonomous change in aggregate change in autonomous consumer spending times 1 plus MPC squared, and so on. And this equals our multiplier. This is a geometric sequence that eventually equals 1 over 1 minus MPC, or y, and this equals our multiplier of that multiplies our $1,000 effect on the overall economy, or GDP. So digging deeper into this impact on the GDP, we see here basically the change in GDP over change in aggregate change in autonomous consumer spending is basically the same. Basically summarizes or is the same as our multiplier, 1 over 1 minus MPC, that results from our geometric sequence from the previous slide. So this equals our the overall chain reaction that our $1,000 has in the economy. $1,000 is not just $1,000 in the economy. It can be, let's say, $10,000 impact on our economy. So this brings us to another question. how does government spending and a government tax cut differ? Well, using our change in the multiplier, we can see that in government spending, the government first spends, say, $1,000 into the economy, and the people who receive this $1,000 then save part of $1,000 and keep spending, let's say, another $800, and so on the multiplier. But however, a tax cut, the government does not directly insert $1,000 in the economy. The government first allows households to experience $1,000 worth more disposable income, and then the households save part of the $1,000. So we don't start off with $1,000 spending. We start off with, say, $800 spending, and then $640 spending, and so on. However, with government spending, $1,000 is directly inserted into the economy. So we start off with a larger sum. We start off with $1,000, and then $800, and then so on. So government spending usually has a larger net impact on GDP at the end of the day. So for our final clues, basically, our multiplier basically leads us to conclude to a basic economic principle that government spending usually in the short term has a theoretically larger and more efficient impact on change in GDP than a tax cut. And this results because our consumption chain results from an overall multiplier from a change in aggregate spending. The change in aggregate spending then multiplies into a larger impact or effect on GDP in an economy. So thank you, and see you next time for our next video. Bye-bye.